So, hello everyone. Welcome join our another community meeting. And today I will give two topics. I will firstly introduce the 3.3.0 release content, and then provide you a demo, small demo that I'm leveraging NebulaGraph with DBT and to use DBT to transform the tabular data from different sources into a graph database, into NebulaGraph. So before the topic, I will first give some updates of the project. And we recently released the fix of the 3.2 and the minor version of 3.3. And recently we have a bunch of fixes and performance improvements. And one thing to mention is that one of our community user from a Chinese company called Hi Goran, welcome. Okay. Okay. So one of our new contributor is working on a bunch of different RFCs. One of them are user-defined functions that they are using it in their downstream folks. Another one is about some specific filter push down. It's related to some optimization of the performance. And they also introduced yet another flat sampling feature. And there are more actually. They were hacking NebulaGraph in many ways, so quite interesting. And another thing is we recently have a bunch of new users leveraging the Nebula NG Betis, which is a Java ORM in the fashion of the MyBetis. So there are some fixes related to it because it is heavily leveraging the parameterized query, and we hit some core bugs in this project by the users, and they were all fixed. So some others are we have newly contributed by a user of a Python ORM. I'm not sure if I already shared this last time. And we also have a new project called Nebula Real-Time Exchange. So it's leveraging the capability from the Flink CDC and help us sync data from MySQL in a streaming way. This one is new. This comes from one of our new contributors in the community from the Binka. This is a organization. The main contributors is the W Drost is Will. Also, he's in our community. So this project is targeted to making your application running on Java that was on top of Neo4j easier to adopt to NebulaGraph. So you basically just need to make minimal changes on your codes to make it running on NebulaGraph instead. So it's quite a young project. So if you're interested, just feel free to check that out. And as I mentioned, we have a new release of Studio that I will give a demo later. And we have an operator of new release. So yeah, I will share something about what's new in the 3.3.0. Okay, I will use slides here. Okay, so this time we mostly sorry, we mostly are leveraging changes in the stability and the performance. So we have a bunch of performance optimization PRs, and we don't have too much newly introduced features. So one of them is we support the where clause in get subgraph. So we will later we will finalize the find path with the where clause fully supported. Previously, we have some limitations there, and we didn't make it to make it included in this release for the find path. But now the subgraph supports where clause now. This is small function that we can cast between the type of time step and date time. And also the session pool, as I mentioned before, later I will give you an example. The one of the major change in this release is we choose to switch off the tagless or bare vertex by default. But if you are already relying on that, you can still use it, just switch it on again. And I will show you some newly features on the tooling, specifically on the graphic visualized tooling later. So on Studio, we have what you see, what you get schema tooling, and you can also view your schema in a visualized way. But it's in best effort. I will expose more details later. And we have a quick starter, so it's just a welcome page. And inside that starter, you can easily load some quick start data set in this quick starter. Later I will show you. On dashboard, we have a bunch of new features introduced, but some of them are relying on other components, so they are not released in this this cycle. But only one feature finalized is called is the process metrics. I will show you later. It's just some metrics on the single process. And on the Explorer side, we have some more features. This is the edge aggregation. And the Query Builder, we can support the Explorer to be embedded in the iframe. And now in our workflow, we have a new algorithm, node to vect, introduced in the Nebula Analytics and the Explorer. I will show you in the demo later. So this time, as I mentioned, we have a bunch of performance improvements. So there are some, most of them are match related, and we already shared a performance report, and you can refer to more details there. Maybe not yet in English, but I will check. We have in the match count, we have the QPS with 2 to 8 times improved, and we with only 1 in 5 latency. And for the 3-hoop query, so we have QPS in 40 to 100% of improvement when we went 1/3 latency. And we were testing everything on 3-node environmental deployment in the LDBC SF100 dataset. This is the specific capture between the 3.3.0 to the baseline, which is 3.2.0. So we can see this is the match count QPS and the match 1-hoop count. Okay, 2-hoop. And this is the goal in 3 steps. So as I mentioned before, we introduced yet another operator called distinct dist. So this helps in this scenario. This is the where clause introduced in the subgraph. So previously we don't support this, and now you can add where follow dot degree is larger than 90, and star dot point player age. So be sure to check out the documentation on this referral character, and there are some certain limitations out there. So be sure to check out the documentation. Session pool, we introduced the session pool for Python, Java, Go, and C++ in the client side. So in that case, you if you are running Nebula, your application is the online service, you don't have to maintain your own queue of sessions. So the idea to provide a session pool is that you don't have to redo the authentication in every query. Instead, you make them in a queue, and you ensure they're alive, and you just put them in memory, and your concurrent queries can reuse this context. So you don't have to call the authentication flow every time. So it will be optimal when your service is sitting on one space and stick to one space, and you just keep read and write queries. So previously, a lot of users would they actually need to implement something like this, and we try to guide them to, you should implement something like this, but it's not always, there are some issues and not always not that optimal. So it's a common thing. So we decided to implement in the SDK side. So this is an example. So you just provide the information of the GraphD, and be sure that the mindset of the session is binded with the space. So you should provide the space, the information of the space, together with the credential. And afterwards, you will have a pool of sessions. And every time you want to call it, you can just directly use the execute. It will be a lot easier. A lot of session related handling logic can be decoupled from your application logic from now on, if your module fits the session pool module. On the other hand, if you need from your application code, you want to create schema, drop space, and switch space. In that case, you should use the connection pool and create session from there instead of leveraging the session pool. The session pool concept is binded with the specific space. You can switch, but it's not designed for this case. Yeah. And and this is the time step and datetime type casting function. So you can just use it. Previously, it's not supported. So a lot of users is urging to request this feature. And finally, this is the tagless. So this is a quite big change, but frankly, from my observation, most of user they don't need a tagless. But when we introduce this concept, a vertex is not mandatory to have at least one tag binded. And that means if you delete one tag, those vertex only with this one tag were not deleted. They became the bare vertex. And that's in most cases, that's not users' expectation, and brings a lot of more complexity. So we listened the user's voice, we changed it. So now by default, this tag less is turned off. That means if you, as before, as you are doing it in 1.0 and 2.0, if you drop a tag, those vertex with only one tag will be deleted. And this is the these are the corresponding configuration flags here in graph and storage. Okay, then finally, I want to show you something about the Studio and the Explorer. So this is a tooling called the Schema Sketch tool. It's introduced in both Studio and Explorer. So I want to demo it lively too. I want to show you here. So this is the new Studio, and the schema drafting thing. You can, you can try. You can just drag and drop things here, and then apply this schema to any space. So it's kind of fancy but usable for users. And on the other hand, if you are you can also view schema. So yes, as you have noticed that for a long time we didn't bring we didn't bring this, a quite straightforward feature, was due to the reason that in NebulaGraph's graph module, you don't have a constraint on the given graph edge type on how the starting node and the ending node are tapped. So we don't specify the tag of per edge starting node and ending node. So in that case, it isn't easy to draw this picture, but in most of cases, people actually make the logical constraints in their mind. So they when they define the serve edge type, they actually in their mind they won't put the team in the starting node. So we bring this, we assume this this is correct, which isn't always, frankly, but we do our best to just making data to sample a couple of samples and trust, assume that every edge in the graph only have one tag, and they are all consistent. So we just try our best to draw this schema. And I consider this is actually quite useful for most of the users. Okay, then let's see what's next. Okay, this is the schema view as I showed. Another thing is the welcome page. So in the newer version, we put a bunch of useful information in the welcome page, which is a new feature. And we also introduced the capability of loading some starting data sets. This is also open source, so anyone can contribute their data sets here in our Studio repository. So now we have only 2 data sets here, but personally I'm planning to put some more data sets there to have the fresh users to get familiar with different typical use cases. And okay, yeah, this is the data starter. What's left? Okay. Oh, then I will show you some dashboard. So in the newly released dashboard, we now add some more metrics, newly statistic perspectives. For example, this is the context switch total for per one process. This is the CPU seconds. I'm not sure this is new, but number of aggregate executors. So I guess this is new. So be sure to check out documentation on the metrics and the documentation of the dashboard, and be sure to set up your own to see what's newly added. So this is the page that you are heading to on the service, like Graph or Meta, something like that. Yeah, and for the Explorer is the enterprise only tool. One of the thing is the edge aggregation. So like when you have between two nodes, like in Nebula, you can have different ranks. That means different instances of the a pair of nodes, that the relationship between them. So now you can aggregate them. Like these are two edges, you can put them into one. And sometimes it's helpful when you're seeking the information insights from the Explorer. Another one is Query Builder. I'm sure you have already seen. You have already seen things around the. Around the Query Builder, but I will show you really quick. So with the Query Builder, you can. Oh, I need to specify a space, and then yeah, you can like drag and drop to write queries, something like this, and you can see. Okay, this could be a query. Oops. Oh, this is not. This is underlying relying on the index, that so it cannot be queried. Okay. Okay, this is the query composed by this drag and drop, which is kind of handy. Final one. This is the iframe, so you can embed the whole tool in your internal tooling web page. Some of the users require this. Finally, this is the node to vect Porsche. I think you may be interested in this. So I will show you in the workflow. Workflow is a tool that you can yes, there can be. Later I will talk about this Porsche question. So I will demo you the newly introduced algorithm node to evac. So for example, I want to do it on the follow edge, and make the degree as the weight of the node to vect, and I guess so. I will save it. Try to run it. Oops. Oh, okay. I'm using a wrong I'm using a wrong environment. I'm sorry for that. Okay. Sorry. This one was configured properly with the backend analytics. So I'm trying to with this is a newly introduced one. So I'm trying to get data from this one, and using, for example, follow the edge type follow as the relationship that I will do this algorithm. So yes, trying to save it and run. Actually, with this workflow, you can pipeline different queries and different algorithms in a DAG way. For example, you can put you can add different output to another algorithm. This is possible, and that's why we have this interface. And after that, so the source of this algorithm is from a space that it will scan the data directly, bypass the GraphD. It will scan data from the storage D. But on the other hand, you can also do this on top of queries. You can do that. I didn't do that, but you can. It's possible. And the underlying, it's calling the Nebula analytics. So I'm going to, oh, something is wrong. Results. Okay, maybe I'm using a test environment. Something was some other guys is infecting me in this algorithm. So this is embarrassing. Okay, so this is the newly introduced algorithm. Okay, I think that's all from this topic on the 3.3.0. Sorry for this demo failure. I will answer the question first. First one from Porsche is edge aggregator. This is can there be more than one edge between two nodes? Yes, this is possible. It's because NebulaGraph have the data module of NebulaGraph for edge. You will have 4 tuples to determine one edge. So that is the tab and the source and the target vertex. Sorry, this is a type. This source vertex and destination vertex. And there is a rank field. So if you are not aware of rank, it's because it can be omitted. So by default, you leave it. If you don't provide the information for rank, it will be left as a 0. But if you want to, for example, you want to module the case that one person will purchase a couple of different times it is supported also with, yes, exactly. You can have and for example, you can have multiple instances of transaction between one people and one one shop. That's one possibility. You can have multiple edges between 2 vertex. But as Goran mentioned, you can just have multiple edges just on different types. That's the more straightforward case. I mean, yeah, for same edge type, you can do that. You just introduce the rank, like you can put your time step in the number or in the int and put this field in as a rank field. You can do that, and that's something make NebulaGraph unique and different from other graph database as well. So about node to vect, I failed to run that demo, but it was a pretty small data set. But you can run pretty large data sets because underlying is relying on the Nebula analytics. It's Nebula analytics is a proprietary. We built it on another open source project, but we release it in a closed source way. It excels in the resource utilization. If it's inserted for same, it will be over. Yes, as Goran mentioned, back to this topic, if you insert one pair of source and the target vertex with certain types, you didn't specific rank, that will be 0. If you insert it a second time, it will overrate of your first edge. And that's basically because we don't have a so-called ID of an edge, and we assemble this ID with the full tuples. So if you insert a second time, so the ID or the full tuples is exactly the same, so it will be override instead of creating a new instance. Okay. And Porsche, if you are interested in the node 2 vector, you can apply for another round of trail to see that feature. And you.
So, hey Wei, I'm
Yes.
looking at your earlier demo, the Studio or Explorer. I am seeing a different view. Is it different from the community version? Can you go back to your Explorer?
You know this?
Yeah. So I'm seeing is different experience. So is this different from community version?
Yes, exactly. The in community version, we don't have this workflow thing. So it's a DAG manager. You can create your pipelines, and underlying all the algorithms on the workflow, and you can actually also create algorithms on the Explorer. Here there are some algorithm tools. They are not the one in the open source version. If you check it in documentation, you will see the graph computation. Where is the graph computation? Oh yeah. So you will see there is a Nebula analytics. So this one is the close. It's a proprietary another one project in our community. It's enterprise only offering, and that will have a better performance and resource visualization utilization comparing to the open source one. But the open source one.
Can you give me an update? How do I buy an enterprise license?
You can just as we talked, we can talk it in the email thread that we have
definitely.
some.
Okay.
Yes, I'm not quite familiar with the business part, but they can have a price with you, and either I'm not sure if you can purchase the algorithm, the analytics only, but you can talk about that. But if you
let's take it offline.
Yes, thank you. Yes, and as Goran added, if you have some properties there, so yes, exactly. The second time of insert of exactly same full tuples will rewrite everything. So sometimes it's unexpected, so you should ensure you are using the right way of writing data on this perspective.
Can you talk about backup and recovery in 3.3?
We didn't have much more update in this cycle yet.
Okay.
Yes. We were trying to bring some, but we didn't make it in this cycle. Yeah, but we will have another cycle of the enterprise only version later, and there will be some more things included in the backup restore. Yeah. Okay.
And any security improvements in the 3.3?
Security improvement. Do you have any specific scenarios? As I recall, there is no PRs related to security in this cycle as well.
I recently reported a lot of vulnerabilities in the.
Okay, CVE, and as I recall, it's after the release. As I recall.
Okay, so it isn't coming in the next release.
Yes, exactly. Yes, yes. Oh, thank
Okay.
you.
Okay.
Yes, sorry, I even forgot that. Yes, thank you for your reporting on those CVEs. Yeah. Okay, so I will go to next topics. So again, it's another topics I prepare. So it's a small demo on how we can leverage DBT to make some graph modeling and do the transformations. So it may be not that helpful to you two guys, because this is more for the fresh users on how they're in their mind module to map the data from a tabular module to a graph module. And I make it to an end-to-end example to help the fresh users to play about it. So the background of this topic, so this is actually a sub project when I was writing another topic around how you can leverage graph tech and graph DB to create a toy level recommendation system. So I reviewed all the methods we can do together with GN. And I need a data set and in a graph manner. So I have to create my own. So then I decided to leverage DBT, which is quite fancy in this domain. And why not make it another small demo? So the task here is we need to analyze what data we have. So we can think of it as a job when we have in our infrastructure or in our service, we have some data placed in multiple places, and we want to make the transformation to leverage the graph thing, and how we can do that. So we need to define how we want to place those different information from different sources into a graph, into a knowledge. And then we need to define the schema of the knowledge. So this is required in schema for graph database, right? So it's quite different from other graph databases, which is schemaless. And then finally, we need to extract how, after we define how we want to extract data, we can make the engineering thing. We want to extract them from different sources, and finally ingest to NebulaGraph. So in first step, we need to see what we have. So in this example, I will release that article later on the recommendation system itself later. So those who are interested, you will get more, have more ideas on that. So the conclusion was I need to abstract grasp information from two data sources. One is called OMDB. So it's a movie data set. It's a public open source, kind of open source project. So there are some all the movie names and the classification of the movies, and all the workers, the crews of the different movies, a lot of information, and some other informations like the covers, exactly. And another data set is the moving length. So it is a data set help the people to do the study on the recommendation on how users are watched and rate different movies. And so it's a data set from a real world, and they just make the sensitive information mask. So I on purpose I combine two data sets to demonstrate in our real world we will combine different data sources in different format and different infrastructure and put them together, make the correlations. So this is a simple but kind of simulation to the real world. So finally, I decided to leverage four kind of edges. So it's used for the content-based filter, which is the term in the recommendation system, and the user-based collective filter. So there are two naive approaches of the recommendation system. So they will together will require our knowledge graph on the user and the movies to have these full types of edges. So this was actually drawn by the the new feature in the studio. You can draw it like this, and afterwards just click. It will help you generate the DDL of the schema, and you can load it into a graph space. Quite handy. And then, well, what's next? We need to after we define the schema, we need to transform the data from different sources into our graph. So let's look into the first data set called OMDB. So in OMDB, there are a couple of different tables. Think of they are just tables, but they are formatted in the CSV files. So there is all movie table with the column of movie ID, the name, the languages, and this is official translation, so we don't care about this. So basically, you have a unique ID towards their names in different language. There is an all casts table reflecting between the movies and the persons. So the job ID is interesting. They are just numbers, but if you look into job names, they are reflected to different job roles. For example, in English, job ID 1 means in the writing department, etc. So you can be a producer of a movie if your job ID is 2. And finally, we have the all people table or CSV file reflecting the person ID, just like here, the person ID to its names. So this is the typical how data are persistent in a relational database. They don't duplicate information, and that's why we sometimes cannot use them, to actually reflect the correlations. It will be a cost if you don't duplicate things, right? Okay, so I just show you full tables to, with those full tables information, you can have one type of edge type, which is the person directed. I'm sorry, the direction here isn't right. So movie will be directed this side, this direction, movie directed by a person. And actually, you can also have the movie acted by person, right? So it's a similar thing. And so by this directed by, so it's an edge. So you will find the starting nodes from either it's a movie ID or so here it's actually starting from the a movie to a person. And for the movie ID, you will find the job ID. You should filter, the all cast table, where the job ID is a number reflected director in the job names in English and English. So you can see it's actually a kind of different tables joined, right? And similar, you can have the movie vertex. You have the ID in the all cast table, and those names are in the all movies. Maybe you want to filter the language as English. Similarly, you can have the person vertex, right? So basically, that's only for directed by or acted by, and we have a different like movie have categorized by. So it's similar here. So basically, I draw the table that required to constrict to have this property graph information. We need table in this way. And we have those 3 types of edge edges now. Then we will leveraging another data source to help generate this information of the user or people watch or rate a movie, and that will comes from the movie lens. Sorry. And the movie lens, we have this rating.csv. So it's a table reflecting user with a unique ID and a movie ID and with a rating. So this is a edge type, and we can put the rating as a property of this edge. And of course, the timestamp, if we want, put here. So what's the problem here? The problem here is this movie ID. They are mapped to specific movie in title in the movies.csv in this data set. It's actually we need to correlate it with all the movie graph knowledge graph in another data source. So they should be correlated because you can directly use this movie ID. So this movie ID should be mapped in some way. So by nature, you just map them with the title. So the problem here is in this data set, your every title has a quote of the year of this movie, and they are all in English. So we can know that if we want to link of the two data set in a certain join way, we need to remove this suffix and search from the OMDB and only for those English titles, right? So we need to do that to make everything connected. So previously with the OMDB, we have this mapping relationship. And together with the rating and the movies, we are doing this. So basically, we are adding the user from here to this graph. But when it comes to the user watched or rate movie, the movie ID should come from the all movies in the OMDB. But we should translate this movie ID with the title and with some transformations and search it in the all movies English name, and so that we have the movie ID in the all movies of the OMDB. So that's the thing we want to. It's quite it's a simple case, but quite typical in our real world scenarios. So finally, we want to, afterwards of the transformation, we will have some record. It's still tabular, but it will be injected to the graph module line by line. So in every line, you will have the user ID come from the movie lens, the rating from the movie lens, the title. They should have in both movie lens and OMDB, and the movie ID. So we will replace it as the OMDB movie ID. And finally, we have this user watched movie with the rating as the property in this edge, right? And it should be something like this, right? User watched the movie, and everything was connected with the tabular data in this colored lines, and we have the directed, acted, and with with the category. I don't know how to pronounce
Hey,
this.
can you hear me?
Yes.
So I wanted to ask you a question, like, how do you model a user watching a movie multiple times?
If you okay, this is a good question. So if in my current module, it's not doable, but if we want to do that, we need to bring this time step into the rank of this this type of edge. So as I shared to you, oops, sorry. Let's see. So oops. I think I have a better related.
So basically, essentially, what you're saying is, if when the source ID and target edges are same, we are saying use rank as a
Exactly. You
Okay.
can see this at rank in the insert clause in the insert query. This is optional. If you omit this field, it will be persist at 0. So rank will be 0. So if you don't care about this capability, it's not a curse. It's just a gift. You can ignore it. But when you need it, you just basically add, for example, add yes.
Is specifying rank a cipher feature, or
No,
your
it's a Nebula native concept. Actually,
oh, I see.
yeah, in Cipher world, there is no such thing. It's something unique in Nebula. Because
Okay.
the background of the team, they comes from the Ant financial Ant, so they were used to working on things around the Alipay. So in their use cases, they have this requirement, so they bring this into this module. Yes.
So we also observed when the data set is huge, meaning billions of nodes and billions of edges, Cipher queries are not performing better when compared to native features. Have you observed the same thing?
Exactly, and we are continually optimizing that. And for example, in this cycle, we did a bunch of optimizations on that, because the cipher is writing a cipher pattern is easier for users, but a lot of constraints were not actually applied. You didn't precisely tell how the query was done, like the native ngql. So we need to we are trying to make it closer in the performance comparing with the native queries, because in native queries you will actually do every step precisely, just like that. But the drawback is if you write it in this way, it's not that flexible to write some multiple direction patterns. So we have to do the trade-offs but generally, if possible, if you can write a query in native, you should do that instead of the Cipher. But in long term, the Cipher performance will be closer to the ngql native query language. Good question.
Thank you.
Yeah, thank you. So I will continue. So we have this modeling things ready. So then we want to, do this transformation. But how we can do that? Of course, you can do it in any handy tools you are using. But this time, I just want to try DBT because it's really interesting to me. So it's just a opinionated way to do so. I just use the DBT. You don't have to use it. You can use everything that's fitting your requirements. So basically, I'm using DBT to do this transformation in this step, just like I mentioned in that diagram. And then I will output the data into CSV and finally use the importer to ingest it to NebulaGraph. So in DBT, DBT is a tool, open source tool, just to help you only do the transformation in the ETL pipeline. And it's assuming that you are putting your data in one data warehouse. Of course, you can extract data from different sources, but finally you will do this transformation in one single data warehouse. So in this demo, I'm using the Perman's warehouse, just one Postgres on a single poor Docker container, but you can use any other things. And DBT supports a lot of different state-of-the-art infrastructures. Either it's open source one or a cloud one. For example, you can do it on Google GCP, BigQuery, etc. So everything was actually already composed in my blog post, so you can know more details, and all the codes are also open sourced. But I want to quickly show you, walk you through a demo, so you have to ideally in short time to have more ideas. So first, I set up everything in my server. And DBT is actually one package written in Python. So I create a virtual environment and install it with paper. It's a package manager in Python. And I installed DBT hyphen Postgres. So this is a plugin that when DBT is doing the transform, it's leveraging the Postgres as the data warehouse. So it will help us install the main package as dependency of. So one package here is enough. And then I initialize a project of DBT. So it's a project. So DBT is a whole mind module of how you want to make your transformation in the modern engineering way. And all of the metadata you want to describe this transformation are file-based, so you can do the GitOps of this DataOps thing. You can put everything collaborated in the central Git repository. So when I initialize this project, I will have a couple of dummy files in this folder. So you can see, so DBT have its own infrastructure to help you set up the module in a web documentation way. So all those information can be presented some way by others, so you can see it in a quite modern and fancy way. So you of course you can describe it in a readme.markdown, and the meta or index or entry of the project is the project YAML file. So you can describe things, and everything else will be described and mentioned in this file. For example, the module, which is the core concept of the DBT transform module. So module refers to how you want to do certain transforms on certain data sources, and you want to output it somewhere else in this transformation. And on the specific transformation roles, they are defined by the circle files, because when we're remember when I was saying how we want to make certain data or information from those tabular sources into our graph modules, actually those record or files to be injected to NebulaGraph are still tabular, right? How they're mapped, they can all be described by SQL, right? And they are actually just joins and some functions manipulations. So later I will show you how. And this YAML under this module file instance of the folders are describe the columns, and those circle files are describing how you want to do the transforms. And there are tests and something else. If you're interested, just try it. So I'm not going to delve into all details. So then we have this DBT project. Then we set up the environment for our experiments. So if you don't already have some equivalent thing on DataWorm, or you don't want to make things dirty, you can just let me make an ad hoc data warehouse. So I add this -RM. So this means when you stop this instance, everything will be wiped. And I didn't map any data volumes inside. So that means everything will be wiped, nothing left. So if you want to have a long run environment, just remove this RM, so you can start it again and have everything resumed. And I set up a Postgres in single container. And then I download the files of different sources. I just put it in this this folder. So this is I just defined it. It's not a form a existing name in the DBT. I just create this, and later you can see how it's invoked. And I download the file from the OMDB org and the movie lens datasets official websites. And I did some data wrangling to pre-process some specific, like escaping characters, and some words just copied as is. So the destination of the file was under the seed. So seed is something defined already in DBT. It means if your data sources are CSV, you can put them under the C's directory. And you C's its concept in DBT help you to inject the CSV data sources, and afterwards you just run the DBT seed. It will help you inject everything there. So I have environment here. So this afternoon I put things under the seed, and then I run the DBT seed. It will take some time because I'm using a single machine Postgres, so to insert everything. And afterwards you can see all of the raw data were already in our warehouse. It's just a Postgres, and you can see all the tables are already there. For example, the all casts. So yeah, you can see you don't have to define any schema, and everything is just injected, which is quite sweet, right? Then we come to the transformation part. So I create this transformation module called the movie recommendation, and I will show you with the example of the user watched movie, this relationship. This is the most complex actually. So it's modules. So everyone is reflected to one relationship. For this is a user watched the movie. And so what it's doing is you just as I do you remember the diagram? I just join select and join things. I select the ratings user ID and the movie ID from the ratings CSV. So this is a movie lens ratings .csv. And I also yeah, I select the title with the movie lens movies, right? The relationship comes from the ratings underscore ratings CSV. So the name, the title comes from the movies with the movie ID. And I remove the the suffix of the year in the quote in the end, right? And then I have the user watched movie with the movie name, and then I need to translate this movie name into the OMDB movie ID. So then I continue doing this another join towards the all movie CSV. So this comes from the OMDB, right? I'm doing this join on the title with all movie name with a like clause, and filter those names in English. So then finally I will have a user watched movie. So if you see, I'm using this client to, so it will be mapped to user watched the movie. So yeah, this is the final one, and you can see this is the result. And I didn't write this perfectly in one go. So in practice, you just I'm using a extension of VS Code called SQL Tools, so it can connect to Postgres and other popular databases. And after you connected this, you can for sure you can disconnect. Yes, disconnect and connect, right? After that, you can, for example, I will show you another one, like movies or with category. So you actually writing the queries here, and you can run it at any time. For example, I can add a limit like 8 and collect run on active connections. So it will help you, run this query. So then your query is valid, and then you can continue write another one. And after you finish them, you can call them by oh, this is, sorry, I didn't mention, this is there is a schema YAML inside this module, right? For example, this user watch movies, you will describe the metadata of this transformation rules. There are 3 columns, and there are even test fields. So this test is related to the another capability of DBT. You can run DBT tests to ensure your different kind of constraints can, you can ensure your quality of your data in a controlled way. So if you are interested in, just dive into the documentation. So with this module being said, you can then trigger a transformation with DBT. So now, for example, that one user watched the movie are reflected here, the circled part, right? As I mentioned. Then you can run this with the name of this circle to trigger this this run, and afterwards you make everyone ready and run them accordingly. So I can run you on the fly for one of them. For example, we can see we already have, for example, this with category, and we can drop this table. So and now you can see this table is gone, right? And now now we can run this dbt run. So dbt will help us do this transformation just in the back end of this plugin in Postgres. And then you can see yes, it's back again, and the data can be preview as well. You can select the source ID is the movie ID, and the destination ID is the category ID. Like I also have this one. It's reflecting which category ID are in certain category, musical, right? So let's continue. So till now, you have every transformation ready, and the transformed data are in a tabular format in your Postgres. Then you can make it reflected to the NebulaGraph, the DML query, right? And we can leverage different tools like in Nebula Exchange, you can do the Postgres connecting to NebulaGraph directly. There are a bunch of different ways. But in this example, I just make things simple because we don't have a large scale data. You just export it to CSV. And then finally, I'm using NebulaGraph importer. Importer is the most lightweight injection tool. It's just a single file binary of written in Golang. You just specify where you want to with the configuration file. You just let the it know how you want to map your CSV files towards your graph vertex or a vertex type, which is tag, or the edge type. So for example, the people.csv, I'm going to map it to a vertex or tag, so we can see what we got in the actually here, after we copy after we copy it to the files, we move everything to this NebulaGraph folder. So you can see here is the transformed data, for example, people. So here I'm using a format of the header so that you don't have to specify which column are mapped to which vertex. So here I'm describing the header as a person.name in this column, person.birthday in this column, and the VID string in this column. So it will directly have everything known by NebulaGraph importer. So with this, you can just call Nebula importer. This is a containerized importer, and consuming this importer configuration file in YAML, you will have everything injected in NebulaGraph. And yeah, this is a example in I want to know why we will recommend this movie to user 124. So we just do a find path. You will know, this is the path with the most reasoning possibilities, because it could be most of the cast and crew of the one's favorite, he rated this Star Wars, I don't know which of them, in 4.5, and also they shared a lot of different connections with this movie. So of course it's another Star Wars. So we will know the reason why we want to recommend him or her this new Star Wars in this find path. So it's just a simple, naive example. But afterwards, you will have a whole user and movie knowledge graph with this process. And so everything was done by in this way and in this fashion. So we just with dbt seed, we make the CSV files from different sources into our data warehouse. And with the dbt, we defined our mapping rows in SQL. We tested it and it works. And then we use dbt run to run this transform. And afterwards, you will generate new tables hosting those data you want to inject to NebulaGraph. And finally, you output it as CSV and inject to NebulaGraph. Okay. And that's, I think that's all from today. So thank you, everyone. And feel free to let us know if you have any questions about today's topic. And check out our Slack channel and GitHub repositories. If you want to discuss anything about Graph and NebulaGraph, go to our discussion forums in GitHub or our Slack channel. So thank you. Let's call this an end. Bye.